Meh. Hold on, I need to fix something. I think it's actually going to want me to do... I think it's probably looking for a specific window, maybe. Give me a second. Cooper, please be quiet. Let me stop for a second because it's going to keep trying to switch back, but I don't know why. There we go. Tools. Start. Close. Beautiful. Hey. Hey. Quit it. Stop. Go lay down. Go lay down downstairs. If you're going to make all those noises. It's ridiculous. Gotta la vida, baby. All right, let's make sure that I'm okay. Good. Okay. So let's see. I'm going to probably end up having to go over this a little bit to kind of burn some time while I'm here. Let's see if so one thing that I looked into off stream was this. So okay, so I'll back up just a little bit. So I was trying to clean some things up, and one of the things I wanted to do was add a struct to the GLSL with some different properties, and then define a uniform. Like so, here we have a light, and I want to just define a uniform light. And when I did that, the OpenGL library that I was using didn't like that. It was saying unsupported type. And so I looked in the code just to check it out. What's up, man? And basically there was no support for that, so I added a pull request and submitted it, which fixes this issue. It's not that much code. It's just basically he has a generic parser in there that tries to map uniform types to the built-in types that he has in his engine. And so what was happening was it wasn't paying attention to any sort of custom defined uniform types. And so we just added that parsing step to his little parser, and it now is fine. So, what's up, man? How does it go? He bullied me the other night, man. Okay. So, some things that I've changed. Not much. Basically, I added those structs and that's it. But I fixed the lighting for, I think, what is the last time. So this is what our lighting should actually look like. We were very close. One of the things that we were doing with the light source that we shouldn't have done is we were using like a linear approach to how we were using distance as the intensity of the light, and light doesn't behave like that. Light uses attenuation, is I think how you pronounce this. In fact, I'm going to actually make sure that I'm pronouncing this right. Let's see here.
Attenuation.
Okay, attenuation. And attenuation is the reduction of the force, effect, or value of something. So light follows very closely. I'm not sure it's exactly, and I'm not sure this follows the exact physics of light. But attenuation is essentially taking a constant value, a linear value, and a quadratic value, and kind of it's more of like a there's a comparator that I'm trying to think of here that I could use, but it's essentially it's a God. Why can't I think of this? There's effectively a point system. Oh my God, it's on the tip of my tongue. I'm not gonna think of it. It's essentially like a smoothing function. It's a way to like reduce something, and most of the times it can depend on like oscillation or something like that. But it basically is a way to reduce the effectiveness of something smoothly over a distance or over a time. And then our function, it's distance. It's based on distance. So we use the distance. We apply this like smoothing reduction formula, and it gives us better light qualities. And then so when I started looking at a lot of the light-based stuff, I was thinking, okay, well, we can actually split up the light into 3 different types of color. We're not using specular yet, but hopefully maybe we will. And then we have our constant, which is always really going to be 1 in our case, and a linear and a quadratic value. And these are going to be applied to kind of give us that smoothing effect. Yeah. So a lot of my experience in OpenGL was mostly 1.0, which is like direct mode, which is like old school stuff like GL begin, GL triangles, and then like GL vertex 3F, and then like adding a vertex that way, and then GL end, like that sort of stuff, which is actually pretty intuitive, to be fair. Like, it's pretty nice to do it that way, but it's just not fast, and it's not very modern. Get out here. Get out. Annie. Hey. Get out. Come on. Come on. Out. Cooper. I'm not listening to that crap. These dogs, I swear to God, they're beyond annoying. So, come on. Sheep. Sheep. Go lay down. Go lay down. Go lay down in your bed. Sheep. Ridiculous. I just yelled at him, and then he started doing it again. Yeah. Yeah, Unity will help you through that sort of stuff. But So anyway, I mean, technically I'm using some type of engine here. I mean, this is an engine. It's just not a huge engine. It just provides the basic stuff into OpenGL, which is nice. Anyway, so we've made some little GLSL, and here you go, just for you, Bo. I changed GL frag color, so we defined an out frag color now, so that we're meeting standards. I updated the names of some of these. In position and in normal are predefined by the little engine that I'm using, so those have to stay like this. Anyway, so like I said, basically we had an issue where our basically if we defined a special type, and I'll go through with how to actually pass these to the shader, because it's pretty intuitive, but I honestly I was like, whoa, that's weird. I never actually knew you could do this. But so we define like a struct, and essentially what this does is just lays out these types in a linear fashion. I'm pretty sure that that's all it's doing. It's just a nice little, it's an easier way to like read this. And then we just define our uniform as a light. But here's where it gets a little cool, or here's where it gets cool, because instead of like having to pass a light object here as an actual uniform value, which if we modify the OpenGL library, we could make that change. But instead, all we have to do is just use light dot position and set the, so it's basically just like accessing it's the uniform name, which is light, and then dot, and then one of the properties. Really cool. I mean, and really easy. And I like this, to be honest, because it just gives you a better way to write this code in a little bit more of a, I won't say, it just is a little bit more flexibility in terms of GLSL and the language support. Yeah, I honestly had never even done that at all. But it seems handy. So anyway, what I was saying is this little engine that I'm using, this little OpenGL engine that I'm using, this little, it didn't support it. And so I added support for it, and then I added just a pull request right here. So hopefully he'll see this and add it. But anyway, the modified binaries I will commit to my stream or to my branch. So it's it will be available if you're following along with the source code or anything. But yeah, anyway, so it wasn't a very difficult change. But basically the issue was this, is that it was looking at the vector types, or it was looking at the uniform types, and I was getting this exception because it didn't know what a light or a material was. So we were doing uniform material, and it was going up, I don't know what that is, and it was throwing errors. So all we did here, very simply, is we just keep a dictionary of these types. We basically look for anything defined as a struct. So we look for that keyword, and if we run across that, then we store the struct type name, and then we look inside that type for any properties. And as we come across properties, we add them to the inner types, and we add them with the name and the GLSL type. Then down here, when we parse through the uniforms, we check to see now, hey, do we have any types containing that struct name or that type name in our structs? And if we do, then we use the dot format right here, the tokens.text dot property name, and we add that. And then that allows us to still get type-based support for that stuff. What's up? All right. So I think, go ahead, ask your question. I'm going to kind of just run through what I want to keep doing here today. Is I think we want to continue to kind of abstract pieces of this out. A hash set is what you want. And if you want to use your own hash function, you just, whatever object you're inserting, your T object, you would just override get hash type. Yes, you just use contains and then T. I know it's weird because I'm typing and then I'm also talking, and it's probably, there's a delay, but okay. So we can actually do don't feel silly. Don't feel silly. Some of the names are very counterintuitive. I found C#'s containers to be a little bit weird. Let me get them water. Cooper, hey. So the list collection would work, but you're gonna get order in or max. You know, you're gonna get. I'm not sure if you know about Big O notation. That's maybe it's a more normal term, but it's a pretty academic term. But it's basically, worst case scenario, you're gonna search through the entire list to find something, whereas you're looking at order one which is, it's immediate lookup pretty much. I mean, despite hash function overhead, it's immediate lookup. Hey. Right. So hash set is what you want. Hash set is what you want. I can show you what I mean. Like, so let's make a little test run here. So I'm just going to make this little, I'll just make a private class, foo, and I will, public override hash code, not hash, sorry. So this is what you want for your hash function, which so let's say your object, let's say it's like this. Let's just say you have a private vector3 position. We'll do public vector3 position get set. And for the hash function, we'll just return position get hash code. And we'll assume that position has a pretty reasonable hash code override. Which, I will be honest, it's a lot harder to hash vectors than I thought it would be. Right. I mean, a dictionary is technically more, a dictionary is essentially the same thing. like all a dictionary does is map the hash of one object to another object, and a hash set just maps the object's hash to itself. This is the only difference. So it's in a lot of ways a set is lighter. So here's what's nice about hash sets. It also guarantees exactly one. Or it always guarantees that if you have one that like it's there for good. Like, sorry, I'm not articulating this properly, but let's just make one. Let's make a hash set foo set, and I'll show you what I mean versus trying to like verbalize it. So if I have foo set, and I want to let's just say add. Let's create a couple of these. Var F1 new foo F1, and then we'll set this position to new vector 3, and we'll do like 550 33. Okay, so that's one F. Let's create like a oops. It really needs to be at the end there. So var F2 equals new foo. Position equals new vector 3, 10, 25, 30. And then let's make one more, but it's going to be a completely brand new instance, and a new vector position, but we're going to use the same values as the first one. So this is what's good. This is what's good about this. So if I do add, so we'll do add F1 foo set that add F2, and then this is a cool part. So if foo set dot contains F3, we'll just write line console dot write line has foo 3, something like that. And so we should get true here. Why didn't it actually write anything to the console? I guess I'm wrong, but I would have assumed. Did I type this wrong? You're going to catch me on something that I didn't know is what's going to happen. Hash set or hash code F1, and then we'll do hash code F2. I would have, with almost 100%, I would have just with certainty, I would have been so sure that that would have returned has F3, like without question. And then F3 you get a hash code. The fact that it doesn't is concerning. Yeah, so why didn't they have the same hash codes? What does contains do? I'm honestly completely at a loss here. Why? I don't understand why it makes it hard to read. It's right there. I'm basically setting F1 to a new foo. The type is right there. I mean, I'm not saving much typing, but sometimes you do, especially if it's like a long generic term. I use var all the time. It's super helpful. It's like auto in C++. Program in C++ for a few years and see if you don't like shorthand or inferred types. I promise. You would change your decision. Um, to be honest, I don't know why this isn't true. The hash codes are the same. Oops. Doesn't have F3. I really am. I'm at a loss. Do you have to use insert? It doesn't. It just doesn't even make sense. Am I reading this wrong? Are these not equal? F1.get hash code equals F3.get hash code. They're equal. This is not how hash set is supposed to work, just so you know. There's a reason why it's called hash set. And it's supposed to use the hash code. Okay. Although it says this is the same as dictionary. What it says it does is it uses the hash code first, and then it compares for equality, object equality, which is, to be honest, stupid. Yeah, yeah. What? But why? But why? That's not how this. That's not how. That's not how sets work. You're right. You definitely have to override equals, but it's because the hash set compares hashes first and then looks at object equality, but that's ridiculous. Um well, okay. Basically, we would need to use, if we wanted to do it this way, this is what you would just have to basically create another hash equality, equality, compare and then use foo, and then implement. Yeah, see, that's so aggravating. And so what we'll do here is we'll just call these things equal. We'll return. I'm sure this has to support like nulls and stuff too. If null equals x, what? Oh, never mind. If what is it? Default? Oh man. See, this is why stuff like this drives me crazy, because it's very clear what I want to do. But you have to do so much typing just to do it. I don't like how it does that default crap. Let's just I mean, this will probably explode. Maybe it has the So there's one of two ways you could do this. To me, both of them are equally dumb, to be fair. There should be something automatically that just uses hash equality. But this will, yeah. So that's gonna work. But that, to be honest, that's counterintuitive to me that you should have to do that. But your question definitely opened a door of WTF, because that's weird. It's really weird. Yeah. So I mean, you can see now it believes that it does have an F3 because it's saying, but hash sets are special because they get like basically they use a hash function to insert something, but clearly these have buckets. Like it's clear to me that multiple objects can have the same hash code but also still exist. Like basically it's hashing it, and then it's using like, there's lots of different ways of handling collisions, like hash collisions, but the more common, there's like you can use linear or quadratic indexing after that, or you can use buckets. I like buckets because it just lets two things have the same index. Anyway, that's at best that's shit. You didn't. You didn't. This is definitely enlightening. Although let's see what happens if we do this. So if we do like dictionary, we'll do foo to 10 or int, sorry. And so here's what we'll do. Here we'll say what we can do. Foo set f1 will equals 1. Foo set f2 equals 2. Contains key. Right? This is, yeah, same thing. Same thing as dictionary, which is complete garbage. I didn't even see what you asked, Bo. Oh, you're talking about the Black Knight? Anyway, So yeah, so dictionary actually works exactly the same thing. I got to be honest. I'm bothered tremendously by that. So you've really opened a door for me cuz this is I'm like completely blown away here. So let's do this. So let's do f1 equals foo. Let's do f2 equals bar, and let's do f3 equals foo again. Right? New instances of a string. What is this going to give me? So why does this work? Yeah, Bo. So here's what I'm doing. So in so collection APIs, like basically in C++ you have a vector, set, queue, deck. You have all these data structures that you can use to hold collections of objects, and they all give you different pros and cons essentially. So for example, like a vector is always linear. Like you always have like one thing gets entered after the other. In this case, it's like a list, I guess, but a list is pretty multifunctional in object oriented. So like Java has the same sort of thing. It has lists, it has queues, it has decks, it has all of them have array, right? But array is the quote unquote primitive. So Colt, I guess what my point is, right? So it's apparently not reference equality. It's just equality. I think you're right. So the idea is basically this. So Bo, the problem is intuitively the way that I would perceive the way that a hash set would work is it wouldn't look at equality at all. I would only perceive hash set. So when you create a hash set, a set only contains one of each thing. So if you try to add something that hashes to the same, and there's a collision, right? So a hash function in this case takes the object that you pass it and runs it through some sort of algorithm that gives you an index. It's called a hash function. It gives you an index in the collection. So instead of when you search for an object in that collection, instead of having to look starting at 0 and just loop through each index until you find the object, you just say, does this contain this object? And it says, okay, 1 second, passes it through that function, gets an index, looks in that index directly. It's like straight to it. It says, yeah, we have the item, and it returns it, or it returns true. So it basically provides you a super fast way to look up things. It's as powerful and fast as your hash function. So in order for sets and dictionaries to be fast, you have to have quick hash functions, and you have to have little collisions. You want to reduce the number of collisions because collisions cause other steps to have to be taken. And so what in my mind, and this may be even based on false information. But the way that I have learned to use hash sets and dictionaries and maps is it's solely based off the hash function and not off hash function and then equality, because I think that's bogus. I think it should be up to the implementer to define one thing that provides the lookup. Right. So what Colt is saying is basically, and I asked why does this work, and he's saying because it compares these two things even though they're completely different instances. So it leads me to believe that it doesn't equality for strings is not based on reference equality, which is comparing memory locations of each thing. It's based on this equality. This. So but because equals is an object, it drives me freaking bonkers. Basically, you just at this point you just say if is it assignable? Would you say .foo? No. I think that's interface. Oh, yeah, it'd be type of foo. I think you can also just do like is. So if foo types are not assignable from object, wow, just wants to keep adding parentheses. Return false. If null equals obj, return false. And then you would just return foo. Well, then we can probably cast it here. Var foo obj as foo. And then we can check null. And actually we should check foo obj. Foo obj. And then return foo obj. Not position equals position. Probably like that. And I'm guessing that vector 3 has position. Okay. So we can go back. Let's go back to our foo example here. Let's switch this back to hash set foo, and then call this foo set equals new hash set foo, new foo, and position equals new position, new vector. 25, 150, 33. And then we'll do the same thing for F3. And F2 will be 1, 2, 3 or something. So we'll do foo set dot add F1 dot add F2. And then we're going to check if it contains F3, and this should be has F3. Okay, so you're right. It's hash then equality. Value equality, yes. That's correct. And we should also be able to do this. That should be a legitimate check. And I guess that's because of this guy. But, you see how kind of, that's a lot of typing. So, yeah. So the first check is hash code equals, and then equals value. So contains runs 2 checks. It checks hash code first, and then it checks value. All right, I guess good to know. I couldn't have told you that off the top of my head for sure. I would have been completely wrong. Definitely not definitely not the same as like unordered map. We're going to use these everywhere for a lot of things. But the reason why is because they're fast to look up things based on position, based on name. Most of the time, we'll probably use dictionary and not hash set. Hash set is useful for mapping hash functions to itself, whereas dictionary is good at taking one thing and mapping it to another thing. So like in cases where you have a lookup by name sort of thing, you can just use a dictionary. Anyway, and he asked a question and I answered him completely incorrectly and then decided that I would verify my work and turned out to be completely wrong. So that happens. Also, Colt, I looked a little bit more into the compression of the vertex or the vector compression. So with a 32-bit float, 22 of those bits are used to encode the decimal. And so 10 of those bits are required for everything else. So the maximum number of bits that you can throw away is 22, which means that the maximum that you have to keep is 10. So the little compression algorithm that you're using is throwing away 21 bits. So you're most of the time, it sounds like you're almost always guaranteed to get at least the first decimal or very close to the first decimal. I hope that makes sense. So it actually doesn't degrade over time. It's just that you're throwing away the data. You're throwing away 21 bits of data on each vector or on each coordinate. You're basically storing as much information from that 32-bit float into 11 bits of data. So it's not actually a compression. You're just throwing things away. But that's fine. I mean, to me, if you get the value, like if you're getting a number like float a equals 0.345, like, I mean, if you get something like that shit is expensive. Like nobody wants that. Nobody wants to be dealing with a float like that. So instead, what it sounds like it does is it just chops all that off and you get 0.3. Anyway, it's neat. I will probably end up using it, to be honest, because I hate sometimes how floating point arithmetic leaves gigantic point values. Okay, so let's see. Let me come up with a few goals for like the next 30 45 minutes and then we'll so we have this. Okay. Fair enough. You're definitely not quantizing it because you don't have any relative position to base it on. Well, I mean, yeah, but you're just that's not compression. That's slamming bits. Like you're basically taking the same amount of data and you're just changing the way it's stored. But it's not necessarily compression. I mean, compression is basically taking one thing and being able to reduce the complete total size of it. You're starting out with this one, you're throwing away this many, so you're losing all of that data. You're throwing it all away, and then you're just slamming bits into a float. I mean, I guess you can, in some form of the word compression, you could call it that. But it's really just efficiency. You're maximizing, you know what you want, you know what amount of data you want, and so you're throwing away what you don't want and pushing it into, a different storage. All right, yeah. So a uint, right? Sure, whatever. A 32-bit data structure. Yeah, and yeah. I mean, and that is even better, right? I mean, that's even better. Like storing it into something that can encompass all of these. Now, if you have 11 bits per component, that's still 33. That's still 33 bits. Uint would be the correct choice since it's unsigned. But you're still short a bit. All right, so let's see here. What do we want to do today? Viewport, main camera, shader. Yeah. I just wanted to know this. I think my focus was, what is the significance of the scale? And the significance is that it throws away everything but the first decimal place. Because 22 of those bits represent that decimal. Oh, okay. Okay. So, yeah, so that gives you 7 bits to put something else in there if you wanted to. And granted, I mean, if you're just uploading like a vector, that's probably a little bit too much. But if you're uploading a shit ton of these things, if you can pack an entire vertex or vector or voxel into a single uint, that is super powerful. Although and you just, I mean, the only thing you would have to worry about is how expensive the packing is. Like actually performing the packing and uploading it to uploading to GPU is not important, but packing, running the compression. It's I mean, it depends on who you ask, but I would refer that to as some pretty efficient bit packing. What's up?
Come on, kill me, I'm here.
Hey man, thanks for the follow. I appreciate it. Definitely appreciate it. How's it going? We're kind of discussing a bunch of things that aren't even close to relative to today, but we went down that road, so I'm entertaining it. So we've cleaned this up a good bit. It's actually pretty impressive. We've got this cleaned up a lot actually. So let's talk about a naive approach for a quote unquote renderer. Because knowing about OpenGL in a lot of senses is okay. At least in general. But just suppose we wanted at some point in time to switch to DirectX for rendering. There's a lot more to that than just what I'm going to explain, but let's just this needs to be, let's keep this interface here. Let's just kind of define what we consider to be a renderer, and based on what we have here, like let's do this. I love this. This is why people take margins seriously. If you're ever wondering why people do next line margins, I mean, why do people do next line code and the same thing? It's because margins, man. They like to keep two source files up at once. Well, so Colt, apparently, and this you probably know more about this than I do, but apparently, using 10 bits for the U and the V instead of 11 would remove the decimal completely. Oh, man. My little camera position didn't take into account that I had my solution window that wide. Okay, that'll be better. Anyway, so let's go back here. Let's go back to, we got main up. Let's just see exactly. So whenever we render, we are, that's an update. We're basically taking a shader and we're taking a camera, and these are objects. So let's for right now, what is cube transform? So let's just assume, like, at the least, this is our render. So a render right now, it eventually will contain a scene, but we haven't abstracted any sort of scene out yet. But right now, it needs to take, God, what I think it really needs is the shader and this thing should be separate. But cube is an eye object. So we haven't come up with a way to attach geometry to an object yet, but we're going to need to figure out a way to do that. And maybe I might have jumped the gun here. So let's revisit renderer in just a second, but we're going to keep it open just to kind of ensure. But what we need, so we've done a few things. We've come up with the ability to keep the rocks, this rocks object, separate from the geometry. Yeah. I don't know. We'll get there. You might be right, but you're trading something. Like if you reduce from 11 to 10 bits, then you're losing something else. It's just not clear to me what you are using based on this stuff. Times 0.5 plus 0.5? That's like some sort of that's some sort of poor man's rounding. Yeah. Yeah, that's like a poor man's rounding function. Anyway, we'll get there. So we need a way to attach an object and its geometry. And I'm trying to think of a name, by the way. Someone give me a good name. A name for object. So we have an object, right, that we can enact certain things on. And we have the geometry for that object. And I'm thinking about two things concurrently here. What do we is it wrong to assume is it wrong to stick the geometry on the object? In general, I feel like those two things are very different beasts. We could use generics, and we could use like IROX object T and force T to actually like This is probably okay, to be honest. We can probably get by for now. We could call it an entity or a renderable. I hate that. To be honest, I hate that. Okay, let's do this. Let's do this. For now, we'll table this. I don't want to waste any more time here. Let's for our render, we want to pass render a camera. We want to pass the render a we're gonna have to get specific too here. This sucks. Anyway, this is not gonna work well to the next point I was trying to make. But let's just say what we'll do is we'll pass a object, the geometry and shader program. Eventually, we'll have something like void render, camera, and iRock scene, perhaps. Oh my God! Hold on one second. Someone gave someone, I know who. My wife taught my daughter how to send me text messages. She sends me 500 a day. It's insane. So my point eventually in creating this render class is to essentially, or this interface is to essentially be able to render our core things without having to worry about any specific implementation. However, this VAO geometry, this particular parameter, is specific to our OpenGL engine, and so we're basically not able to completely abstract out all of this stuff yet until we can figure out how to include this with this. Essentially, that's how I feel right now. And you know, my original thought was just, hey, yeah. Anyway, I'm not going to worry about it right now. We'll just keep this defined loosely, and we'll create a new class that implements it called like OpenGL render. Even though it's not perfect. We're not going for perfection first time. We'll come back and we'll make this better. For right now, it's staying like this. And we want to public. Hey, Mary Tyler, I'm working on some things. I will text you later, okay? Jeez. It's sweet, but I like this. Boop. Thank you, IDE, for knowing what I wanted. Why does it? And the way that we'll actually render this thing is pretty much identical to the way we would render something in our main. Oh, also we'll probably want avoid clear and float RG, float B, and I guess A. Oh, that needs to default to 1. We should maybe let's just make it clear for now, because you can clear other things too, like depth and stencil buffers as well. So we'll just make it clear for now. And then here we'll want to implement this. Avoid clear, and I believe this is just camera projection, camera transform. There'll be other stuff we'll need to do, like update this stuff. And then under render frame was basically viewport was fine. We don't need to actually update that. Oh yes, actually we do. So we'll set viewport to camera. Why don't we have, interesting, I thought we had a viewport, but we don't. Let's do that. So public viewport, and get will return viewport. Brilliant. Okay. Camera.viewport.x. Camera.viewport. We can probably just simplify it here. Var viewport equals camera.viewport. And then we'll propagate it that way versus having to resolve those properties every time. Viewport.x, viewport.y, viewport.width, viewport.height. Okay. So the viewport, what else do we do? Yeah, see, GeoClear, in our case, does this depth buffer and color buffer. Will probably allow specifying at some point, but not right now. Let's see what else here. What else are we wanting to do? We need to oh, interesting. I forgot about this. So our shader doesn't actually So our VAO has a shader program attached to it. I forgot about that. So we don't actually need... Damn it. We don't need this. Although, what's tricky is I feel like when we remove this, once we abstract this out, we will absolutely need to add shader back. Program, I think. Yeah. So we're going to set projection, view. And what is our view? Oh, and our model. Really, we just need a scene. Because now we're not going to have lights. We're just going to hard code this for now. We're just going to hard code it just to ensure that it gets propagated correctly. But this is going to depend on some other things later. What was our light position? This. So we'll just hard code this for now. That's fine. I'm good with that. And then our model matrix is set value obj transform. And then we're going to do shader use and then geometry draw. What were the N1 values again? Actually, you know what? Technically, we can do this here. We don't actually need to do that. We can just do that here. And we don't need this anymore. And okay. Get rid of that. We will move for now. We'll just move this stuff to here, to initialization of this guy. Although one day we will want to probably modify these from here. But this is fine for now. We want to create a new renderer probably right here. So private iRenderer. So let's create, whoops. Our renderer is going to be new OpenGL renderer. We create our new shader. Let's create our shader here. We'll just go ahead and set some basic values on it, I guess. So now that we have this all separated, let's create just a, all we're going to do here is private void init shader. And really what we should do is like this. And then return shader. And let's remove some of these separators now. So what we're doing is we're going to create our renderer. We're creating our cube. Our shader is going to be, actually, even better than that. Let's do, oops, shader program. Have it return a shader program. We'll do new light shader. So it'll be like a little factory method. New light shader, and then let's oh. Oh, damn. Never mind. I was trying to use a constructor initializer here, but I cannot do that. And then here, from here, we can do a VAO, and we'll do new cube with light shader, and then var cube VAO equals, and return cube VAO. And then here we can create, let's see, our cube VAO. This is our geometry effectively, is we'll just do new cube with light shader. We don't need this. This is going away. Let's put this up here to kind of show order. Just instance properties here and frame throttling. Forward needs to be up here with the instance properties. This is our frame throttling stuff still. QVAO can be more scene object. Wait, what does this say? Scene stuff? Yep, there we go. Let's call this cube geometry. Geometry. Okay. And then this, we should put this, we should keep this with our cube object. Okay. So we've reduced effectively a lot of this. We have a new renderer. We have a new cube. We have new cube geometry. And then we have a camera. Where did the viewport go? Did we blow away the viewport? We did, didn't we? Oh, no, we didn't. Yeah, viewport's getting set up here when we create our new applications, because our viewport, basically, we want it to be our screen size, our window size. Anyway. Although it's interesting. Yeah, so we create, oh, let's see here. Oh, man. I wanted our window to be separate. So essentially swapping buffers is what flips everything to the scene. So individual draw calls will actually draw to the back buffer, but it won't actually display until you swap to basically most things use double buffering nowadays. It basically just means you're showing one buffer while you're drawing to the back buffer that you can't see, and then once you're done drawing to the back buffer, you swap with the other one, and then you start drawing to this back one. So basically, you end up with a very smooth transition each time. You don't actually see what you're drawing until you call swap buffers. So we definitely don't need this. So let's just keep swap buffers outside of the renderer for now, because the renderer, all it needs to be able to do is just make draw calls. That's what we want. And so let's remove this. Okay, so update scene is going to make all our instance translation stuff, our instance updates to like our objects and stuff like that. But here is where we want to call renderer.render. Actually, we want to call renderer.clear. And then we want to render using our main camera, our cube object, and our cube geometry. And then we want to call swap buffers. Amazing. We have the same result. This is the type of stuff that drives project managers wild. While we just cleaned up a shit ton of that main object, that very not flexible vomit code area, we now have like this cleaned up, slightly organized, implementation with real objects. Amazing. So, I'm still kind of like back and forth between whether or not it's, because we're clearly getting some value out of abstracting out some general things like a camera and a renderer and an object. So we're getting value there, but what I'm constantly battling with is figuring out where it makes the most sense to abstract things out and where we're going to get the value from. Because, right now, like, we don't need to update viewport anymore. Let's see, update viewport. Nope, we don't need that. We can make this. We can actually make this utility on the renderer. We can actually make this like a string version. Yeah, we'll just make it a getter. And then our OpenGL renderer can actually implement this. But we'll implement it like, so we'll do it a little bit different. We'll do, let's see, public string version get, and we'll have it return string.format. OpenGL version blah, new line, GL version with the 1. And by the way, if you haven't seen this before, this type of, all this is string replacement. Wherever I have these little curly and an index values, basically the value inside the curly brackets represents the index of parameter that I'm about to pass next. So the first parameter, I will pass whatever goes here. Second parameter, I pass whatever goes here. That's all it is. So string.format blah there, and then where did this stuff go? It's GL get string. So the first thing is, so we'll return string format that, and then that's the first parameter, and then the second parameter is here. Okay. So this is nice because now we've abstracted that. That's another good thing to take out of the main here. Sorry, the main should be really over there, but let's see. So let's create window, and then like let's just add a little line here that does console write line, and then render version. So we're gonna get that same compatibility profile context. Interesting. We have our main camera constantly looking at this stuff, the light and all that stuff. So really what we're going to want eventually is something that is aware of a scene. And what we want in a scene is kind of like camera, lights, set amount of objects, that sort of thing. We're getting very close to oh, we don't need this anymore. So let's get some of these window methods here. We want create window, dispose scene, swap buffers. This is probably fine. Create window, swap buffers. Can almost, well, window is what? Nice, we can warp the pointer. Show cursor. Set screen mode. Oh, nice. You can go to full screen. I want to reshape. I guess that's on like when you resize it. Mouse wheel. Mouse move. Oh. It's got lock support. That's good. And VSync. So, is it perhaps it's time to like maybe start figuring out how we can control some of this stuff? Perhaps. So let's look at maybe how we can handle some input events. So where are keyboard events handled? This is a little bit mind-boggling. It's got like full mouse support, but keyboard events, where in the hell is that handled? I'm gonna have to open the other solution here. And it's probably going to, yeah, I was sure it was going to do that. Sorry. Maybe this will actually work here. So let's see, bounding box, where is, these are like constructs. Where's platform? Window. Input. So do I use an input class? Yes, I do. I use input. How do I do this? Interesting. I just want to know actually how to process these events. Key bindings. Subscribe an event to a keystroke. Can you? I hope you guys can see all this. Oh yeah, you do. You can. Good. Subscribe all. So it automatically subscribes all of this. So like, where does this get processed? Let's find. No references found to that. Why not? Well, it's not clear how exactly we should use this. But there is this input class. What does subscribe all do? It's already, it subscribes. This is crazy to me. This is like, it should be like, what does handle events do? What does this do? Of course, I have to go back into this source code here. I thought that I was referencing the source code. I thought it would let me actually, let's see, what is it? So what does handle events do? Key down on keyboard down. On keyboard up. So it does, it pushes things to keyboard callbacks. Input add key does what? Key bindings are added. Subscribe. Okay. I believe, and let's just test some stuff. So let's subscribe. I don't really know what the what is the character? Like what? God dang it! I don't know, man. I thought that this would be easier to understand here, but it's clearly a little bit esoteric. What is the key? Care key. We use key codes? Okay. I don't think that like it means the actual key. Well, let's just test. I think they're just using key codes. Which don't ask me to subscribe or to So we'll just say on W, and if this works, I'm a little bit skeptical of this. But let's see. Console.writeLine pressed W. All right, so look, we're in here. Let's bring this in here. Whoops. Oh, I forgot you guys could see this window. So let's bring this over here, and if I press W, look at that shit. Magical. Oops. This just reminded me here. Let's actually, let's just make this so you can reset that. Let's not make the viewport read-only. Let's make it so that you can set the viewport. And then let's also make it so let's see. So if we set this viewport, let's set viewport equal to value. By the way, value is the incoming value that's passed in. If that wasn't clear already, but I feel like it was. And then let's view, then all we have to do here is this. So let's actually do this here, because this seems like it's helpful. Yeah, I agree. Like, the premise is good, right? Things feel good, but then when you start looking at like polymorphic getters and some are properties and some properties that have getters, and you want to add a setter in a subclass, and you have to basically redefine the entire property versus redefining. You have to use that weird new syntax or whatever. Yeah, it gets pretty gross pretty fast. And we'll just call this like protected void, and we'll say, actually, you know what? We're gonna call it private because we're not going to override anymore. And we'll just say update viewport, and that needs to be a void return type. Projection should not be read-only, but view frustum can stay read-only. Well, Colt, I mean, we're just not really like talking about compressing vectors yet, so we're kind of behind that. We're way behind where you are in your phase of your project. So I don't want to take away from progress on this, but it also interests me. So I'm definitely willing to talk about it. It's just trying to move forward without getting hung up in any one micro optimization that we haven't even really gotten to yet in this project. So we will, though. We will get there soon enough, sooner than later. So we're gonna update this, and then we're gonna call update viewport, which is gonna propagate everything to our projection and view frustum here. And also, the good news is that when we call render, it's also gonna. So let's do this. This is where I just noticed this, is that when we actually maximized the window, I don't know if you guys saw that, it was all funky looking. So when we create the window here, let's add a on reshape. Oh, well, that's not what I wanted. Maybe on reshape callbacks. We want to add. Is this a list? Yes. Add. And then what is this? Just an action. And so here we'll just basically do this. Main camera. And we'll say viewport equals new viewport. Wait, are we storing viewport? Oh yes, we do. We are. Although I don't know if we made those mutable or not. Let's see. No, yeah, they're definitely not mutable. So they're definitely immutable. So what we'll do is this. We'll say viewport equals new viewport. And we'll press it the window.width, window.height. And then we'll set our main camera to the new viewport. And this should handle, hopefully, I said hopefully, there we go. Although it's weird. I mean, it works, that's great now, but basically what had happened was, so let's just when is this getting called? I feel like it's getting called really early. That's why. On reshape. Oh, okay. So you're right. That is what I missed. You're right. So what it's doing is it's shifting over decimal places. But when you do that, you're losing non-decimal places on another side. So you're right. I get it. I see what you're saying. You're right. You're shifting everything over, but when you do that, you lose bits on the number side. Basically, it sounds like what you're doing is you're taking the decimal and you're removing higher order bits and lower order bits. You're basically keeping this middle part. So it also is you're going to have a hard limit at a specific amount, at a specific float value. You're going to run into you can't actually use a value larger than this. Well, you're losing the smallest values of it, but you're also losing the largest float values too, because if you're shifting it, you're shifting decimal spots out to where it would normally be able to support a huge number and a decimal. Now it's only a certain width. And use any float values exceeding 1. It's so it only encodes the decimal? Because this is only for normals? Is that right? If this is only for normals, then yeah, I got you. So that's odd. Why is it not rendering anything from the get-go? console.writeLine, create window. So create window works on reshape callbacks for whatever reason. Oh, derp. This needs a call update viewport. I forgot. There we go. So anyway, so before this would not work. But now because we're updating our viewport when we resize the window, now we're getting updates. Okay. Anyway, sorry, that was just something I just noticed. I wanted to fix it. We fixed it. Oh, for now, we fixed it. So let's talk about input just for a minute, and then I'm going to take a break. But let's talk about input. Let's just say this. Let's keep a let's remove this rotation stuff, and let's keep a vector for and then we'll just call this position delta. And we're gonna do this. This is probably not super conventional, but I'm just using this as more of a storage technique and not as much as an actual geometric technique. So what we want to do, I think that I just totally got rid of. Anyway, let's init input, and then our input init input. Okay, yeah, that's what I'm. You're right. That's what I was missing, but I get it now. Anything greater than 1, because it doesn't need any it doesn't need any of that. So okay, I get it. And then let's input, and we'll, what was it? Subscribe. Yes, subscribe. We'll subscribe to W. And what we'll do here is we'll just say, we're going to use it like this. The X is going to be, this is why it's going to be confusing. I don't, let's not be fancy. Let's just do what it's supposed to do. Let's so our movement, our WASD movement is going to move relative to specific directions. So what I actually want to do is I need to have an up amount or actually this is be up adjust. We'll just call it up adjust. These are not super accurate. We'll go in the positive direction. So when we're facing, I think our right is actually going to be we'll call it right adjust. And private float forward adjust. Okay, so let's remove this stuff. This is all our old test code. We'll probably end up adding the rotation back maybe later. But what we're going to try to do is we're going to just do a WASD implementation of input where we can like move the camera around. So we'll do W is going to be what? Forward? No, wait, we can't move. Up and down we'll do. Okay, so W is going to be, we'll just do forward adjust plus equals 0.05, I think. A is going to be right adjust minus equal, right? I think. Did I not name it? Did I have a typo somewhere? Is it adjust? What the I can't spell worth a shit. Adjust. Why did I not spell this right? Wait. Oh, I misspelled right. I had a D in there somehow. Okay, sorry, my eyes. Let's see. WAS is going to be forward adjust minus equal, and D will be right adjust plus equal. Right. Right you are, mate. Yeah, 110. Yeah. And then in our update scene, I think what we want to actually do is we'll just say forward direction is equal to main camera, and we'll get forward, and then we're just moving forward and right. And I think I'm only getting up, but I think you can use a cross product of a, yeah. So let's get the up direction just cause up, and then I think that your right direction is just the forward direction times the up direction. And let's actually I need to do cross, I think. It's all right, man. I nerd out about this stuff too. It's super interesting. And then let's normalize all this stuff, I guess. Up there. We should probably normalize all this stuff as we go. There, that's fine. And then we want to, we'll do our main camera dot move, and the amount we want to move is going to be up adjust times forwarder. No, not up adjust, you idiot. Forward adjust times forwarder is going to equal times forward dirt plus right adjust times right direction. And then we will move them out. There's no way this is going to work. I just know it's not, but yeah, well, one reason why it's not going to work is that we should also main camera, sorry, up adjust is equal to 0. And then right adjust 0. Up and then forward adjust 0. I'm doing it separately right now, just to apply the update at once. But why did removing we'll just make it look at it again. Hey. It's very slow, but it's definitely let's just, I guess for whatever reason I thought that it was going to look at it every time. But like, look, we do this right here. But I don't want to have to look at it every time. So why? Let's see how much this is actually what this is doing. So let's move amount. Yeah, so it's not actually moving anything. So what? Yeah. What's curious to me, does getting that forward vector do something? What does it do? Update rotation? Yeah, I don't really know what So look at actually doesn't update the rotation matrix, and that's why this is a problem. So what's happening is we're updating our position, which is setting this to dirty. This is actually not doing anything. Our rotation matrix isn't actually updating, which is just aggravating. Because we want our rotation matrix to represent our position here. Let's peer into what look at does, because that's what I want. I want the rotation piece of that, and I have to get, in some way, shape, or form, I have to get that. So let's switch over to this, and let's look at matrix 4, and then let's look at yeah, I figured it was something like this. Okay, so we do need our rotation matrix matters here. So let's just hijack some of this code. The end of the day, it doesn't really matter, except for we just need our rotation matrix to actually be something. Because the problem is movement. Can we get around this? I think we can. Let's try to get around this. Oh no, I can't, can I? It's still going to want the rotation matrix, and the rotation matrix has to be the transform has a position and but it shouldn't matter, right? Because it's just a rotation matrix. And the position is going to be the fourth piece of this. So could I just zero out the last? Let's try that. Let's just, this is me being completely naive here. Is it going to be equal to the transfer? Can I clone this? Is new matrix 4 transform, and then let's rotation matrix. How does it set those last couple things? Unit W. Okay, so yeah, let's. Okay, hold on. I think we can do it like this. Hold on. So I think we can do this, and we can do transform 0, transform 1, transform 3, and then vector for unit W. Let's see if this works. Of course it doesn't. I don't want to see move them out, but see, that seems right to me. I'm curious to see if and then let's write this one because the second one is going to be right. We'll just call this rot matrix and then 0, 0, and then we'll just do matrix. Because this is going to be the right one. And this is what I thought it was. And let's see if they're equal. So let's pause execution here. Let's go up here. These aren't right. Heh. Okay. Well, let's try that then. Somewhere I messed up, and it may just be my lack of understanding the API, or flipping something on its head, basically needing to transpose it. But still, I mean, still we're getting the wrong thing. And it's not clear to me. It's not clear to me why this is. But let's change this to here. Let's because this is what I want to do. Let's make this. Let's kind of organize this a little bit. This is, I mean, this is essentially the look at, but the negative I. Isn't that what they did? It was like a negative I. Where's look at? Create a negative translation. That's all that is. Still though, okay. Still though, we should be looking at the thing when we start. So why? I'm missing something huge here. And then we need to change this to just call this other method rather than. So let's just call look at obj.position and up. So this is fine. We're updating our rotation, update. Can we get How do we haha haha this is what we want. Lovely. It's flipping the fuck out. But That's better? Oh, man. I think I know why it's flipping out like that, but let's see here. So we want... Really, really and truly what we want is... We'll just say if it's less than or equal to... Y. Oh, that's a... return. The question really is for me is why the fuck does it keep blinking in and out? Like when I'm pressing keys, like it should just be simply updating the position of the camera. Why is it that movement seemingly flips the shit around? Yeah, so we want this to be a rotation matrix for this thing. It has to represent that. I think that we're going to need to manage rotation and translation a lot different, because right now I think we're trying to do too much. So dirty, we're gonna let but rotate is rotation dirty, and we're gonna handle this differently. Look at will not modify the rotation using this, because these forward and up are based on the rotation matrix, which right now is going to be nothing. All we care about is the transform. It's flipping though, but why is it flipping? It means it's dirty as shit, man. No, it means so we're flagging something dirty. Basically, we only want to update. We only want to like merge our matrices whenever we have a change, right? So you don't want to do all this matrix math every time it's like when you initialize something. A lot of people will call, like, if you wait until it's actually requested, it's called lazily loading or lazy loading, something like that. Well, with general, like, pretty complicated or at least expensive math, you don't want to actually make the updates as they happen. You only want to make the updates when they're requested, and so you flag things as dirty. And it's something that's kind of propagated from hardware days, where you had like an error bit or like a dirty bit or something like that. And basically it just says that I've changed this, and whenever you request the full transform, then basically flip those bits back to false and return the most up-to-date value. Move amount is fine. I don't need to keep spamming that. So let me think about how this happens. Basically, our rotation, the look at is different because the look at takes the negative I point. That's what I actually think that my first. Let's try this. I think that my first approach to this was actually right. So let's do transform, and then this is going to be, the first index is going to be, I think, the first row. So what we want is the first 3 rows, but the last row is going to be our translation row. So we want to leave that alone. We want the rotation matrix just to hold the rotation. In fact, really, we only need a matrix 3 to represent our rotation. We're going to leave it as matrix 4 just to keep it compatible with everything else. But this is probably what we want. Until it's not what we want. This is what's wrong with the world today. Is that we're using our rotation to determine our forward and up directions. When we call this look at, the look at matrix that we get out of this is, I wonder if transform.rotation. No, it's not going to give me anything helpful there. Technically, though, this should give us... So what's happening is basically, I'm not quite sure, but somehow my forward vector is getting completely thrown off because but how the hell is this right? Because if you notice when we do a update transform, is it something in our camera? I wonder. Yeah, no, not really. It's not. I feel like we're updating the position here. We are adding offset. But this is giving me something wrong. This is giving me something wrong because I think rotation matrix is wrong. But rotation matrix, it's so weird. It's literally, I think I'm just literally flipping around 180 over and over and over. I mean, that's what it seems like. Rotation matrix, we actually don't need to. A rotation matrix here is just going to be. But like this is what's bugging the shit out of me right now. Is that every time I move, it's in and out, in and out, in and out, in and out, in and out. So is it flipping my forward? So let's just check that. Let's just check to see if it's flipping my forward. I don't know why this is. I thought we had all of this crap taken care of, but clearly we don't. So let's just see. I think that it's flipping my I think so, but I'll try. I'll see. We'll see. So let's just see what happening. I'm pretty sure that it's just flipping me. Like I'm pretty sure that I'm just doing back and forth, and that way every time I hit W, it's actually. Look at that, dude. It's exactly what it's doing. But why? Okay, so let's... Yeah, I mean, that would I think fix it, right? Well, no, would it? Would it? Or would it just do the same thing? Yeah, it's just going to give me the same shit. I mean, the fact of the matter is that somehow this thing is flipping completely on me. The problem is that it's taking the first value is right, and then after that, it's flipped. But why? Why is it flipping it every time? That it literally makes no sense. At least to me, immediately, it doesn't make sense. I mean, I'm sure there's a valid reason. When you create the look at, it creates it from the negative I's perspective, the negative I position. So, but this is after all of this. So why? I mean, the thing is these updates are always going to cycle through like this. So it's always going to have the same behavior, no matter like what I apply to it. It's always going to flip back and forth. There's not going to be any sort of yeah. I mean, the look at essentially does this. The look at okay. So what the look at does? The look at works. The look at creates this. It creates this matrix right here. Essentially, this thing right here. Well, actually, sorry. Let me go to it. If I had it pulled up a second ago, but everything, it makes it so hard. Why I have the source linked, so I don't know why it's being such a pain in the ass and why it won't just link to the right matrix 4. Look at. It's basically creating this guy. But here's the catch with this thing is it's using the translation of the negative I. So it's translating everything See, this is what's tricky. Is I feel like this matrix is right, but it's almost like it's creating the rotation from the negative I position. So it was really that easy? Are you kidding? Whatever, man. I'm sorry, but yeah. Okay. Well, anyway. I was trying to use the transform matrix to derive the rotation matrix. And the problem is that applying the negative I translation was altering that rotation matrix. It's me being naive. It's me being a little bit hopeful of something that's not actually right. If that makes sense. If it like basically I would have to take the transform and then back out of the translation piece of it. Which I used to just think that translation was always a function of well, I mean, if I did that, then I wouldn't be getting the right transform matrix. Right. Well, I guess what I'm saying is this is giving me the correct stuff. But this applies. This essentially what this does is this creates a transform matrix that puts the thing at this position looking at this thing. So this does both. This is a translation and rotation. The problem is that I try to get my forward vectors, my forward and up vectors come from the rotation. And what was happening is I was updating my position, and when I update my position, it changes the look. It does this is the way I create the transform, is by looking at the position plus the forward vector. Was this is probably part of the problem. Is that I'm trying to do a look at just to basically update. But because my look at function moves me and rotates me, then I was fine. But basically what I should be doing is I should probably not use this and just use my own rotation and then have look at actually translate and move me. Hope that makes sense. Anyway, I'm doing a little bit of extra work, but what we're going to say this means is we have to set the rotation, and then what we need to kind of do is just say that now our rotation is dirty. So we're going to say that we're basically going to say look at means our rotation is dirty. And all that means is that before we calculate forward or up vectors again, that we here we go. Right, left. This is actually pretty slow, and I wonder if there's just like a way to determine if it's down or not. Anyway, in short, this is better. But let's go back to our main here, and then let's because ultimately I think what we want to do is we want to actually move this is probably fine. And then we just reset everything afterwards. That's fine. And we can probably already go ahead and just let's do this. Let's do plus this. And then plus we can just already add up adjust times upder. Even though they're not really using it yet. And in fact we can though. Let's add Q and E. Q and E. And we'll just change Q to be up adjust plus equals and minus. Damn it. I hate this keyboard that I'm using. And we'll make this up adjust as well. Up adjust minus equal, and that way we can now use E for up and down, S and D. I mean, sorry, D and A for right and left, and then W and S for the other way. And let's also change like increments. Let me just add like a const. We'll just say move increment, and we'll do like a private const. Well, what do they want us to do? Read only float? I can't remember. CSharp is strange in this regard. We'll just call it inc, and we'll make it like 0.1, something like that. I don't know. It's probably not a great rate, but yay! Anyways, that took a really long time, and I did not expect to run into those type of issues. So I basically wasted all the time that I really wanted to do some other things. But you know, this is what we got. I'm a little bit meh about the about how like the movement works, but that's okay. um to see if a space is empty. The way I would handle chunks is, I think, a little bit different. You know, you could probably track it based on modification. Like when you create the chunk, determine if it's quote unquote empty at that time. And then if any modifications are made to it such that it's not empty, then flag it that way. I wouldn't think that you would want to somehow, I mean, as an optimization, for sure, I don't think that you would want to have to scan it at all. It would be super awesome if it just knew, right? So when you start processing chunks, you're like, this one's empty. I already know it is. Does that make sense? So like when you create the chunks, I mean, you know if it's empty right off the bat because anything that you went to put inside of it was empty. There was nothing in it. So you would only change that if you modify it some way, whatever your modification functions are. If you have a way to modify it, if you change the value in there to something that isn't empty, then it should just set a state on there. Well, when you randomly generate it, you have some memory model of a chunk, right? Your octree or whatever. There's some in-memory representation of a chunk. You have to add things to it. If you add a bunch of empty blocks to it, or a bunch of empty nodes to it, right? Or if there's no, I mean, you have to know the state of the thing. This is we're trying to represent specific things like that with an abstract, like generic data structure like an octree becomes insanely frustrating because you can't represent things the way that you want to represent them to get information out the way you want to get information out. It becomes, how do I force this octree to work with my implementation and not, how can I write something that's going to be flexible for my needs? I would do a full resolution scan. Then I would basically, as I'm generating voxels, as I generate those voxels, I know what chunk they're going into. If all the voxels that I generate for that chunk are sky or air or something that isn't renderable, if every single block that goes in there I know is invisible, then there's then I can flag that chunk as completely invisible. And if for whatever reason I add a block to that chunk or I modify a block to that chunk such that it is visible, now I know that I actually need to render it. I mean, to some degree, you could almost manage all visible blocks per chunk. So you don't even have to do a full scan. But like these are things that like you can't do on the GPU, right? Like, I mean, I guess there is a way that you could somehow encode whether or not each block is visible or not, but there's no way to look at the chunk as a whole from the GPU standpoint. Well, you're not scanning, you're inserting. If you're generating things, you're generating random things that you insert into an object, into the chunk in this case. You're not scanning, you have to insert everything you can into the chunk. And if you insert if you insert all things that are invisible, then you know ahead of time that it's invisible. Like, I can almost guarantee you, it's like, I know when I generate the random voxel data that makes up a chunk, I know if every single thing that I inserted into that chunk is empty. I mean, right? It's got to be. You have to know. Yeah. Yes. That is correct. And that's what I'm talking about. So if you're saying when you say sample or scan, what I interpret that as is here's a chunk. Should I render it or not? Or should I look at each thing in there? Like your GPU renderer that takes an octree, when it decides whether or not it should render something, if there's nothing in that chunk to render, knowing it ahead of time would benefit you. It'd be an optimization because you would know to just skip to the next chunk. You wouldn't have to render anything, so there's no use in scanning through every single possible voxel to check. Right? I mean, that's how I interpreted that. But yeah, I think depending on what your implementation is like, dude. I mean, that's the thing. It's like if you're trying to like skip a few potential voxel units to determine something, then I don't think it's worth it. But maybe it is. I don't know. It's one of those specific to use case things that I'm not sure. Maybe. Anyway, I'm gonna skedaddle. I gotta get out of here. But hopefully, I mean, this is work. This is at least something visible. We have some camera movement. I'm really kind of annoyed at the way that the input kind of is processed. I wish I could like subscribe to. Oh, I can subscribe to an event. What is an event? An event is. Whoa. A lot of stuff. Subscribe key event. Oh, okay. You can also subscribe to chords. That event class is. What is bool state? Anyway. I mean, yeah. I mean, the thing is if you're just looking for, I guess it just depends on what your needs are. I mean, because I feel like if you need the data, if you have to scan the data anyway to determine if there's a visible chunk or not, then you're not getting that many savings because you're not getting that much savings because you're still having to scan it. At some point, you have to get the data. So like if you're getting the data anyway, there's no getting around it. Then why not just determine the whole based on all the individual data versus like scanning bits of it, but then still at some point having to go back and find those values anyway. Like you still have to find the individual data, each data point for each voxel, right? I mean, you can't just scan parts of it and then not. I mean, you're talking implementation details, and I'm not following exactly what. I mean, when you start talking about rendering things on the GPU versus versus creating meshes on the via CPU and then moving things to the GPU, it becomes a completely different ballgame. I mean, there's just so much information that you can determine on the CPU without having to worry about bit crunching a bunch of stuff. Whereas once things go to the GPU, adding new things becomes very difficult, especially if you've already crunched everything you can into these perfect, nice little, UNts, and you need to add something, but you don't have space to add stuff. Like it just becomes a scale problem. And like, sure, you're going to get a super fast engine up to a degree, but you're going to lose flexibility because of it. Well, then, I mean, to me, that's how you should do it then. But, in my opinion, the chunks are designed to a specific size so that they can be loaded in chunks. If like what you're saying is I want to load them in pieces, then it seems like to me what you're saying is that my chunk sizes need to be smaller. I mean, that's my interpretation. Now that could be completely off base, but if you want to load things in pieces, your chunks should be the size pieces that you want to load in. I mean, that's the purpose of the chunk, right? Is to kind of abstract out details of the whole. I don't even see the problem. I don't even see a problem. So why don't you just create a range of chunks that can be loaded into the area at the time? Why like if it's a number of chunks problem, then reduce the number of chunks that you have to load. Like when I did this, when I prototyped this whole thing, dude, I mean, that's enormous. Like, why not as you move around in the zone, load in chunks in the direction that you're moving and keep a maximum amount of chunks that you can possibly load. Like the way that my prototype works is as you move, it will throw away stuff on the back, but there's like a buffer between the two. So like you can move and it won't automatically start destroying things off the back unless you've already reached that maximum. But basically as you move, it starts to move that max in. And so you always have this buffer of spots. Like you can move around without it loading or destroying anything. But you do hit a maximum once. If you stay in one place long enough, it will pop in every possible chunk. But it's just like a huge square around you. So from your perspective, it looks like, it'll keep going. So as you move, it's removing and loading things in. You don't have to load the whole area at once. I mean, that seems like your optimization should be, you need to come up with some general constraints that satisfy the performance that you're looking for. Well, who defines the loadable area? Hold on. Default terrain generator. And let me turn this. So the way I handled this is by having basically a minimum height or a max height. So basically, if a chunk is above a specific position, which looks like there's a min height, and let's see, there's a max height, and then we're coming up with an average in between there, based on what samples? What is in? Based on the noise. Yeah, I guess. So we're kind of like smoothing. We're doing. I was doing some smoothing stuff. And this is also, so here's my optimization. So basically, if I have any sort of non-air chunks, and this is not optimized at all. This is basically like a hack optimization at the end. If I allocate a bunch of air chunks, then I just deallocate the whole block. This is what we'll for our specific walkthrough for the program. This is what we'll do. This is what we'll use. We'll use something similar to this, just because this is super. There's some optimization there with the numbers, just to try to we use like a mask and some other things to like simplify some of the multiplication and whatnot. But in general, I mean, that is what we use. Anyway, I'm gonna bounce. I gotta go. I should have left like 30 minutes ago, but I will be back probably in a little bit. Might stream some Dark Souls, but thanks everyone for hanging out, and we'll see you next time.